pH and percent ionization, just a couple of examples, really. And it's just putting together our two equations. And actually, I might do this just on this screen. Let me turn this thing on. Because on my next screen is the example. But on this screen, I just want to gather up the equations that we need. Now, due to the fact that percent ionization only deals with acids, we only need our acid versions of the equation, all right? And that's a tongue twister. Give me a break. Acid versions. Anyway, we only need those particular equations. So yesterday's equation, percent ionization equals, and that was where we had the H3O plus divided by the concentration of the acid times 100. And we had to rearrange it if we wanted to find the H3O plus concentration, right? We would bring the acid to the other side and bring the 100 on the bottom. That's the same as taking the percent and turning it into a decimal and then getting the H3O plus. So that's going to be important for us. In terms of pH, we have pH equals negative log of the H3O plus concentration. So if we wanted to find the pH given the percent ionization, we could solve for H3O plus and then stick it in the pH equation. All right? So from a percentage, we could get H3O plus, and then we could get pH. We could work the other way around as well. H3O plus equals 10 to the exponent negative pH, which means given the pH, we could find the H3O plus, and then we could put it into the percent ionization equation, and we could find the percent ionization. That's really the more common one. That's how percent ionizations are determined. Using a pH probe, finding the pH, putting it in a percent ionization equation, and getting the percent ionization. All right? So let's do a couple of examples here. So here we've got what is the pH, which means the last equation that I'm going to use to answer the question is the pH equation. I'm just going to put it over here off to the side. pH equals negative log of H3O plus, which means I need the H3O plus from the percent ionization equation. Yesterday, I did this question two ways. Essentially, I need 1.5% of 1.50. Or I can rearrange the equation. I'm going to do this as a rearranged equation today. Percent ionization is H3O plus over the acid times 100. 1.5%. I'm looking for the H3O plus. The concentration of the acid is 1.50 molar times 100. I'm going to divide off the 100 down here, and I'm going to multiply by 1.5 up there. That's going to leave me with H3O plus. 1.5% times 1.50 molar divided by 100 equals H3O plus. And don't clear your calculator, because in a moment you'll go negative log answer equals. all of these POH and pH and H3O plus, they all are used in the next equation. It's like we've got a series of equations here that we use. What do we have for H3O plus? Carissa, you got a number? 0.0225. And that's plenty of significant digits. Let's just hang on to that. So now we're just going to do our pH equals negative log. And I would write it in, but again, remember your calculator. Oops, I dropped a 0.0225. Again, your calculator has that answer button, except for all you backwards calculator people. Yeah, I'm sorry. They are backwards calculators. Anyway, you have to put the numbers in. People who have the cool, fancy calculators, all you're doing is negative log, answer equals, what do you got? Yep. Sorry? 1.65 in pH. Okay? So if it asks, what is the pH? You first need the percent ionization and, equation to get the H3O plus. Negative log answer equals, bang. Okay? Let's do another one. Yeah, backwards calculator people, your calculators are based on a computer chip that was designed a long time ago. Back in the day, back in the 80s and early 90s, actually, these new calculators didn't come out till 2000 sometime. They were all based on these chips that worked in reverse logic. So you always had to put it in backwards like that. They're an easier chip to make. That's why they're in the cheaper calculators. These other ones, they have a chip that uses what they call arithmetic logic. You can put in what it says and you get the answer. You guys have to understand more fully. It takes more brains to use the reverse calculators. That's what you can say to your friends. In this case, we're asking for what is the percent ionization. So that's the equation I'm going to use last. I have the concentration of the acid, and I have the pH, which means I need the H3O plus so I can put it in the percent ionization. pH equals 1.32, and therefore the H3O plus is 10 to the negative 1.32. You could actually put that right into the percent ionization equation. You could have 10 to the negative 1.32 on the top and then just divide off the concentration of the acid. You don't even need to do this in 2 steps, but it's good to do it in 2 steps. What do we have for a number for H3O plus? 0 point something. Yep. 0.48 moles per liter. Percent ionization, the amount of H3O plus. In other words, how many H's fell off divided by the acid times 100. We had 0.048 moles of the H's fall off. That's what the pH told us. We have 0.05 molar hydrochloric acid times 100. Actually, that's only one significant digit. I'm going to put an extra 0 on the back end. Let's have it to 2 significant digits. The percentage to 2 significant digits. Jenna? 96%. Okay? So the pH gets us the H3O plus, which then gets us the percent ionization. And when I said I had 2 examples, I lied. I forgot. There is a situation I want to deal with. Hold on one second. No, I want to go right to here. Let's go to number 4. Because I'm just looking at the time. Okay. We're good. We're just got enough. What if we're dealing with something like potassium hydroxide? How are we going to figure out a pH of a solution that has a base? if I have 0.25 molar KOH, I'm not going to be able to figure out H3O plus, but I should be able to figure out how much, whoops, that was supposed to be an O. OH minus is there. How much OH minus is in the water if we have 0.25 molar KOH in the water? And this is ionic. This has everything to do with the formula and how many OHs are going to fall off. How many OHs are fall off of these things? Yep. Yeah, it's going to be the same number because I have one OH fall off. You don't need to show me that step. That step would look like this. This is what we did yesterday. 0.25 molar KOH times 1 OH minus for each 1 KOH, which means 0.25 molar OH. I don't need to see that step. There's only one OH there. So it's got to be 1 KOH. Or sorry, 1 OH for each one. Once I have this number, what can I calculate once I have the OH? What can I calculate with this number? Yep, Jenna? Yeah, I can get the POH negative log 0.25. But I'm not finished there because the last step is to get the pH. Yep. Again, the POH is just an intermediate number. 14 minus answer equals, except for you reverse calculator people. Got to stop, put some numbers in. What's the pH? Yep, Taylor? 13.4. Okay? Don't even have to look at that number if you didn't really even want to. You get POH, 14 minus answer equals, bang, 13.4. Okay? And I'm pretty sure that's, I got a barium hydroxide example as well. That means there's two of them. Here, I'll let you guys finish that off. And then as I'm handing out the worksheet, I'll let you work on the barium hydroxide. The only difference is there's two OHs in each barium hydroxide. You've got to double that number first before you get the POH. Ooh. So there's the last example, and I will hand out the worksheet, the home worksheet. The textbook feels that these POH and pH calculations are way too difficult for mere grade 11s. I think it's something that you can easily handle, and it's a very good introduction to the way acids and bases work. So there aren't many textbook questions. But when I get to the acid-base section next year in grade 12, there are so many other new things I need you to learn in grade 12 that I want this to be reviewed. And that's why I teach it a little more thoroughly than the way the textbook has it. All right? Actually, that homework on the bottom of that slide, I think, might be the homework I already assigned on the other page. Is that the same stuff? So that's already been assigned. So it's just the sheet that you have now for homework and the textbook work if you haven't got that. Like I said, if I have 0.055 molar BaOH brackets 2, then that means my OH is, and I don't need you to show me those steps. I'm just reminding you where they come from. How much OH minus am I going to get from this when the OHs fall off? Yeah, Amy? 0.11 molar. POH, negative log 0.11. You could write that number down, but pH is going to be equal to 14 minus answer equals. And like I said, this sheet that you do, once you get good at converting from percentages to H3O or OHs, it just is doing the same calculation over and over again using that negative log function. pH value. Carissa made the fake scratch the head move. I got it. No, I don't got it. Yep, tell her. Oh, okay. What do you got?
There's something about halving something.
Doubling. I doubled this. This from here to here was times 2. And the reason why I doubled it is because there's 2 OHs in each of our barium hydroxide. That's why I doubled it. Okay, what do you got? 13.04. All right? The practice is the worksheet. That's it.